Aloha everyone, and welcome to another Carbon 60 video by me, K. Elmer. And in this video I would like to share with you a lot of my research that I've done on the differences between stir and Sonicate when it comes to making C60 oil. So let's start. We've got our disclaimers. This is research purposes only. C60 oil is not approved by the FDA. You understand that making and consuming C60 oil is experimental, and you do so at your own risk. And again, I don't endorse products. I don't get paid. I don't have any products. And this is just purely my own research that I'm sharing. And the most important thing, obviously, is anything I say should not be considered medical advice. All right, so before I get into it, though, I would like to say mahalo, which is Hawaiian for thank you, and we use that word often over here, to the C60 Labs and to Lion Biomedicals. Both of these companies actually contributed to this video, not monetarily, but they gave me some tremendous information that I'm going to share with you to answer some really important questions that, would just take us, for those of us who experiment, it would take us a long time to figure out. These guys obviously make a lot of product, and they've got a lot more opportunity to learn from higher volume of experiments, that they're doing. And both of them were very kind to share information with me that I've included in this video as pro tips. So stay tuned for that. There's some great tips that they've both provided in terms of how to make the best product for C60 oil. All right. So now this is all about the difference between stir and Sonicate, because as you know, when you're making C60 oil, depending on the type of C60 that you're using, whether it's powdered or pulverized, you have a different process if you've ever watched any of my older videos. And so the whole idea, if you're just using powdered C60, you add it to the oil, you stir on a magnetic stir, you let it sit around for a while, you filter it, you're good. Now if you're using pulverized C60, you mix the pulverized C, that's what the PC60 means, pulverized C60, with oil, and you use an ultrasonic machine, and you sonicate the oil. Then you let it settle and you filter. And so there's a huge difference here between stir and Sonicate. And if some of you happen to watch, other individuals out there making videos about C60, you will know that the general consensus is that sonication is bad and don't do it. And I humbly disagree with that, and I will show you the data to prove my point. So let's talk about stir and Sonicate by starting with stirring. Now, the thing about stirring that you really need to think about, and it's a lot more than I originally thought. I just thought, I first started out, I just bought the cheap one on Amazon and started her up, and I didn't think about all the different things that are involved when it comes to using a magnetic stir. So that's what this video is about. So I'm just going to cover this real quick, and then we'll jump into the detail. But there's definitely a difference, okay, between a stirrer and a mixer, and they come in different configurations, whether they're an induction stir or they use an electrical motor, the capacity of the stir. How much can it handle from a stirring capacity wise? How fast does it stir or, spin around? Does it have a timer or not? And then of course temperature is a real big deal, because some magnetic stirrers also are a hot plate, and so you have the opportunity of basically controlling the heat, but at the same time electrical motors have been known to get warm as they're used, as opposed to induction, which doesn't. So temperature is definitely an issue when it comes to magnetic stirrers. The type of stir bars, there's been a lot of conversation in the chat about the types of stir bars, and which is the best one, and which one would you use for what purpose, and it's quite an interesting subject all by itself. And then the stirring mode, one thing that a lot of folks don't really ever get into is what direction are you going to spin your solution in. And then of course the magnetic fields. This is a magnetic stirrer, so it has a magnetic field, and what's the implications of those. So let's just jump right into this. So now this is my little setup here at K. Elmer Labs, and I basically own two of the cheaper Amazon ones that you get. Everyone, a lot of people have these. If you watch all the other videos about people making C60, this seems to be the go-to one. It's a cheap one. It's like $30. And then I also have and these are motors, right? And then I have an induction one right here from Argos, and I just bought this to do other experiments on. not really knowing what I was buying when I first started. But this is my setup. I got 2 motors and 1 induction. And so now, when since this is the one most people use, I do want to just mention that the capacity for this stir on the product, if you read the product definition on Amazon, it's 3,000 milliliters. So it's supposed to handle 3 liters, okay? And it said its speed is from 0 to 3,000 RPMs, or rotations per minute, okay? But one of the things that, when you buy this thing and you start using it, and you all know, I mean, hundreds of you use this one, and you already know what I'm about to say. And what's interesting is if you read the actual product description, which is amazing how so few of us do, and I'm guilty of that too. It actually says right on Amazon in the product description, not suitable for highly viscous solutions. Well, what is oil? Oil is a highly viscous solution. So even though this thing says 3,000, the capacity rating is 3 liters. There is no way, because I'm going to show you this little video I made. And so the thing about this video, this is a 500 milliliter flask, and you see that vortex on the top as it's spinning? That means that all of the oil in the entire flask is spinning. But it's only if I use a 500 milliliter flask. Oh, that's just my little guy. I'm doing some experiments there. Okay, so the point here that I'm making is that if you put a full liter, and you know this, right? You guys do this. If you put a full liter of olive oil on one of these puppies, you won't see the top of that vortex. And if you don't see the top of that vortex, that means only the bottom part of the oil is spinning around, and up here it's barely moving. It's not even moving enough for you to notice that there's even a ripple on the top, which means you are not getting the whole thing stirring. So don't put a whole liter on one of these guys, because if you don't see that vortex, it's not stirring. You're only stirring up this bottom part here. So you've got to basically see that vortex right there, and then you know that everything in the flask, right here, everything in the flask is moving. So like right now I'm doing like this, I'm doing this oil right here is like a bunch of leftover oil. I had leftover avocado and MCT and coconut, and so I just decided to make a liter of just all kinds of oil, and then I put them on and I split it between 2 500 milliliter flasks, and they're spinning around, and there they go. This is running right now. And that's basically the point, though, as I want to make, is that it is a highly viscous solution. It does not. This little guy, even though it's rated at 3, it's only going to handle half. And so I've also heard from a couple of folks in the chat, and they've said the same thing about other machines. So the general rule of thumb, and this is just my humble opinion, the general rule of thumb is that whatever it says, that means it pretty much can only handle 1/3 or less of what it says it can handle, if that. And so, of course, by the way, this is the cheapest made in China kind of model. It is the cheap one. And so obviously it's not going to handle much anyway to begin with. But if I were to buy like a more professional model, like one of these guys, and it says 3,000, I would assume that it could pretty much handle a liter. So I'm going by the 1/3 rule. But even then, I think if you were to put a 3 liter, I don't know though, I'm just guessing, but I'm thinking if you put a 3 liters of oil on one of these guys, I don't know if you'd see the vortex. If you know about that, and you do see that in your own lab, please comment it below and let us know that that you can trust some of these these more expensive, professionally made for real labs types of stirs, okay, and they can handle that level of capacity. So enough about that. So now the idea about stirs versus mixers, is the idea that the stir is simply it spins the bar, and then inside the solution, the actual flask, nothing moves, okay, except the fluid. And it's just that little bar spinning there. You can see the vortex right there, and it's spinning away. Now, some of these magnetic stirrers will also come with this temperature probe. If you have a thermometer on here, this can also be a hot plate. So, but this is the basic setup of a general magnetic stirrer, and of course, it comes in different sizes. Okay, so you can go 1 all the way up to, I think the biggest one I've seen is like 12, and then you can do a lot on one, and of course they're very expensive. And so this is the basic setup of a magnetic stirrer, and then you've got another device called a vortex mixer, and you may have seen this on other videos of other folks. I don't own one of these because I do a lot more than just a little tube at a time. But this basically, you put the tube down right here, and this little black part just, and then it stirs the whole, so the whole container is moving, and it does it really quick, and it just stirs it up like that. But bottom line is that, there is a difference between mixers and stirs, and the topic of conversation here is stirs. So now, temperature. This gets really interesting because, one of the biggest subjects out there is like, if I get a stir, should I get the hot plate? And if I don't have and then of course, and if I do have a hot plate, how warm should I make the oil? Now, if you remember from the rat study, I did a video on that. They stirred for 2 weeks at room temperature. Now, room temperature in a lab, if you've ever been in a lab, they're air conditioned, they're cool. I'm guessing probably like 72, around there degrees. And so that's, quote, room temperature in the lab. That's what they did in the rat study. And of course, everything we all talk about is always tied back to that benchmark study. But so one of the things, so I did go out and look at some of the science literature. I did find 2 studies that talks about temperature and whether or not you want to heat up your oil while you're stirring it. So now, by the way, if you're not familiar with my videos, I put almost everything I'm saying. If there is a link for what I'm talking about, and I like to put the links there so you can read more. I'm only going to cover it from a high level. If you want to dig in, go check out the links in the video description. There is a links. Boy, on this video, there's probably more links than I've ever put in any video. So there's a link to this study right here called Temperature Dependence of the Light Fullerene Solution, Solubility in Natural Oils and Animal Fats. Okay, what this study did was basically they studied the differences in saturation. And they based their saturation was basically how many grams per liter using a spectrometer to determine the amount of dissolved fluids or dissolved sediments of the C60 specifically in the particular types of oil. And so on table 3, it lists a bunch of different oils. And so let's just focus in on olive oil because that's the main go-to oil for that. And so what's interesting about this study is it showed that using that dissolving C60, and I want to point out that in this study, it was only 60% C60 at 99.9% purity and 34% C70. So they didn't just use pure C60, and they only put it 10 hours in what they call a shaker. So they didn't even really kind of use a stir. They used a kind of, it sounds like they used a mixer of some kind, but they basically, when we're looking at solubility and we're looking at temperature, right, olive oil. And so what's real interesting here, at different temperatures here in centigrade, and here's I translated them in Fahrenheit, they were able to reach a 1.2 grams per liter of saturation at 176 degrees Fahrenheit. So, okay, there's 2 points here right now. Okay, this proves that the hotter it is, the higher you're going to get, or the more dissolved C60 you're going to get into solution, which is the intuitive thing, right? The intuitive thing is, if I heat it up, I'm going to be able to stir it in faster. It's kind of like if you've ever stirred, sugar into water. It's going to dissolve way faster in hot tea than cold tea, right? And so it's, this common sense, right? But so what's interesting though, and then so that's that point, right? That heat increases dissolution rate. Now, the other thing, though, I do want to point out is that the kind of like the benchmark saturation in the rat study was 0.8 milligrams per milliliters or 0.8 grams per liter. Okay, 0.8 is the benchmark number. And so what's interesting here is if you look at 104 degrees or 40 degrees centigrade in olive oil, they were able to reach basically, if you round up, 0.8. And so this 104 between 68. Right, this is more like room temperature here. If you were to actually consider it, between here and here, like right about here would be room temperature, and you can see where they basically got 0.5 or 0.47, and then they jumped right up to 0.75 when they got up to 104. So so you can, the rat study guys came out around here. Well, they got 0.8, but they did it at room temperature, so a little bit different. But they were using 100% C60. And they were using stirrers, not shakers. So, a lot of differences here. But the idea here, and this is the point, is that they got as high as 1.2. They had to go really hot, but they got 1.2 grams per liter. And so for anyone out there, and I have ran into these individuals in comment sections, and there's not a lot of folks, but boy, you run into people and they're like, no way C60 can't get more than 0.8, because that's what the rat studies say. Well, guys, come on, really. This study here proves you can go higher than 0.8. You can go to 1.2 just with temperature alone. So, the bottom line is you can go higher. You can get all the way up to 1.2. There actually are C60 products on the market at 1.2. grams per liter in terms of saturation. So, it's a significant point to make that heat will increase saturation. And then the other thing, too, is at 176, what does that do to the oil? We take a look here at smoke point. Extra virgin olive oil, the smoke point's at 350 to 410, and just regular olive oil is 390 to 470. So, it's well below. 176 is well below. I mean, like halfway even to the smoke point. And so in terms of will that temperature, basically destroy your oil just to try to get that high level of saturation? The answer is no, because you're going to be less than half. But at Labs, in my humble opinion, there is a taste like crap point. And all of my experiments that I've done, anything over 105 degrees, that oil tastes weird when it comes back out. And I don't like it. It just tastes burnt. And so I, as a rule, I do not go for the heat equals better and, all that stuff. I don't do this. But I just wanted to show you that there's a study that proved it. You can get to 1.2. And here you go. This is the proof. Now, the other thing, this is the other side of the coin here, okay, is that this other study called olive oil as a biocompatible solvent for pristine C60. Now, what's interesting about this study is they used pure C60. They didn't say, 100% C60, but they didn't say what the purity was. They stirred for 72 hours, and then they used a centrifuge for 1 to 2. That's your, quote, let it settle, right? And so these guys sort of followed the rat study, even though they only went 3 days instead of 2 weeks. But what they got was, and then they measured it in micrograms, was they were able to find, and this is interesting, olive oil here, based on the temperature, was they went backwards and they found that the highest level of solubility of C60 in olive oil was not at 100 and, 176 right here. It was not at 176, but it was at 50 degrees Fahrenheit or 10 degrees centigrade, and they were able to get 5.99 micrograms per milliliters. Okay, now the 0.8 would be 800 micrograms. So, right, 8 milliliters versus micro. Yeah, okay, it'd be 800. So they were able to get 5.99, but what this basically implies is that colder is better. But when you look at the actual amount, it's not anywhere even close to this. So, in conclusion, I really believe that keeping it around, under 105 is probably going to give you the best saturation and not mess up the taste of your oil. There you go. So that's temperature. And of course, both of these are in the links. Go ahead and read them if you'd like. But, I'd love to hear your opinion of it. But, when you're anyway, I won't go any more of that. But it's just real interesting stuff. And I'm a nerd and I love this stuff. Anyway, let's talk about stir bars. Does size matter, or what about shape? Now, I don't know if some of you saw this. I was just kind of dinking around one day and I decided, hey, let me buy a giant bar and see what happens. So this one here on the left is the bar that comes with that little Intelli Lab. This little blue guy, that guy, that bar comes with it. And so that's your normal little bar. So I decided, let's get this monster bar and see what happened. And you can watch this video at your leisure. Okay, and so, turn that off. And then basically I did this little video where I tried to use this giant bar inside of a 1 liter flask sitting on my Telelab, and it was just beyond difficult to kind of keep it steady. I couldn't get the dial past like 10 o'clock, and so I didn't, even though it was bigger, it didn't perform better. It didn't spin faster because it just kept flying off the center of the flask, and so that's what this video showed. So, so the idea behind stir bars, my first thought on that is, bigger is not necessarily better. It really matters. And then what I found out later, and this is my point, what really matters is the shape. Okay, so now they come, not only do they come in different shapes like this, but the white ones are actually coated in silicone. And then you actually can get out and get Pyrex coated or glass coated magnetic bars. So you have different choices here on bars. You can get different shapes. You can have them either silicone or glass coated. In my, again here, but bigger is not necessarily better. But then one of the folks on the chat was so gracious to share the link to this, and the link is in the video description. Courtesy of the laboratory people, they have this chart on this page, and it's It's awesome because what it tells you exactly every single shape and what's the best application. So, this typical cylindrical bar is what comes with the stir, and it's a general purpose bar. Makes sense, right? And then there's just more of kind of like an elliptical one where it's kind of like elliptical. It's not totally round, and that's basically used for cylindrical, beakers. And then you've got this one with this little nub in the middle, and that's really good for any type of flask or beaker that's got a curvature that's up, and you've seen mason jars like that, right? It's kind of curved upwards at the very bottom, so you want to use this kind of stir bar for that kind of glassware. You want to use that for general purpose. Of course, that comes with elliptical version. And then what's interesting is little round guys are for using if you want to do stirring inside of a test tube, and on and on and on. And so what's interesting about this when I read this and was this guy right here, this little triangle guy. I never even knew they made triangle ones until I read this, and this one here is meant for, and its best application is stirring into solution sediments. And that just like the light bulb went off, because when I'm stirring powdered C60 into oil and I'm using this type of bar or this type of bar, when I'm done, I just get this fine black silt all over the bottom, the sediment, because C60 is a powder, it's a sediment. Because you know what? Because these things aren't meant. This thing right here is meant to keep that sediment up into the solution so that you can dissolve it better. So my next experiment, I've got a whole list of them, but one of my next experiments is going to get one of these guys, a triangle one, and to see if it actually gets, if I get a better stir result using a stir bar designed for sediment as opposed to a general purpose one. So, when it comes to stir bars and your magnetic stirs, size may not matter, but shape definitely matters. And there you go. Oh, one last thing. I looked this guy up. It ain't cheap. That little guy right there, like $60 for a stir. So, yeah, I'm gonna have to wait till I get some money on that one. But it's it is interesting, and that's the point, right? Shape matters, size maybe not. Boy, you could really go a long way with that phrase. But I'm just gonna jump right into stir mode. Now, magnetic stirs. There is a difference. Different stirs can do different things. And so now this Intelli Lab, I'm gonna talk about this guy a lot because I own two of these guys. Anyway, this guy right here only goes and spins clockwise, right? So your little bar only going to go clockwise. And so now I've got this other guy right here, and I bought him so that I could experiment with what would happen if I stirred something in the opposite direction. And I can't figure out what would happen. I just wanted to try it, so I got this guy, and I've yet to do that experiment because it's on that long list I mentioned. But this one right here, this type of stir, this is an induction stir, and it can literally go, and I could set this thing to go clockwise, or I could set this thing to go counterclockwise. It's actually in my room right now doing counterclockwise stir on an experiment. Okay, and of course these are the different prices. And so that's what that one does. You can get one that goes clockwise, you can get one that goes either or, and then you can get one like this that can go clockwise, it can go counterclockwise, and it can auto reverse, and that's what's super cool. This is like, I'm hoping Santa's good to me this year, because this is my dream one that I hopefully one day will be able to afford, which is a magnetic stir that can do all three, and it also has a hot plate. So it's like you could do it's everything. It's all in one. It's not cheap, but this is so cool that you'd be able to set it at auto reverse, because auto reverse means it's programmed automatically, and I think this puppy goes up to 90 minutes. So you can set it like every 30 minutes, every hour, whatever. Spin clockwise, then stop, then spin the other way, then stop, then spin. And I believe, and this is just common sense, I guess, intuitively, I'm thinking if you did that, you would probably get the best stir ever, because you're mixing it in both directions, and you're constantly, it's constantly agitating the sediment and blah 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 blah. So you can imagine that if you had some of the different features, as you could really get a lot more creative in terms of increasing the saturation of C60 in your oil, because you've got a fancy stir that can do a lot more than regular stirs, and you got the best bar for the job. So these are some of the considerations for the holy grail of C60 oil, which is try to get as much C60 into that oil, because that way you don't have to drink so much oil every day. So anyway, there's that. So that's stir mode. So now let's talk about magnetic fields. I want to show you something about magnetic fields, because these are, quote, magnetic stirrers. So let me tell you about magnetic fields. And I do need to preface this with something that I haven't mentioned before, but before I was interested in C60, and still to this day, my number one hobby, interest, passion is bioelectrical magnetics. And I've been studying that for well over a decade. It is just something I absolutely love to learn about. It's something I love to read about and practice with and experiment with. And I actually, as a hobby, I collect bioelectrical magnetic devices and do experiments. So I'm kind of a nerd that way, but it's my thing. So anyway, so because I'm a bioelectric magnetic nerd, I actually own probably every type of device you could use to measure things. So I did a test here, and I want to show you this test. Now with this test, I took my my magnometer, okay, which measures a magnetic field. This is a real low one. It's only going to do 10 Gauss. But anyway, what I want to show you, though, is the differences between my two different brands of magnetic stirrers and the type of magnetic field that it creates while it's running. So now first let's take a look at, let's measure the Intelli Lab magnetic stirrer, and I want to show you something here. Plus means it's a south pole energy, and meaning that's the south, basically magnetics have north and south pole. So this is south pole energy, and you can see that the meter literally goes past the 10 Gauss. So it's a very strong south pole field being generated by the Intelli Lab as it's running. Okay, so now I take the same magnometer, to the Argos spinner that's called the thin spin, and let's measure that one. Now you take a look at this, and you can see where right there, you see that little flicker right there? That's the induction. That's the electrical signal going through the coil right here in this induction spinner. And what's happening, though, is it's going on to the negative side, and that's north pole magnetic field. And so, but you also can see another very important thing was that this is a very, very light. It's not even going past 5 Gauss on a north pole magnetic field when I go to measure it. So you can see that it never gets past 5, and it's north pole field. Okay, and so if you've never thought about this before, then it's something I'd like to just share with you, that there is a difference between the effects of North Pole magnetic fields and South Pole magnetic fields. And what I just said is extremely controversial in the academic world. And I know all of you trained scientists are just pulling your hair right now that I said that. But I want to reference the work of Albert Roy Davis, who spent 30 years of his life as a scientist studying the effects of magnetic fields on living beings, and on mice, chickens, you name it, and humans. And he wrote numerous different books. I've read all of them. The magnetic effect, magnetism, and its effect on living systems, the magnetic blueprint of life are just 3 of, I think he wrote about, 8 or 9 books. And so he wrote all these books, and he basically had 30 years of research, and then he hypothesized, and then went ahead and did the research for 30 years to then create a theory that there is a significant difference between North Pole field and South Pole field in terms of how it affects any type of organic element, that could be living or like oil. Oil is still organic, hydrocarbon sort of thing. And then his theory, he basically, I would say proved, but that's extremely controversial. Everyone that takes basic physics in college will completely disagree with me and disagree with Mr. Davis. But basically, he says that even though conventional science thinks that there's a single magnetic field here, like a big egg-shaped thing, and there's no dividing line, and then thus force because there's no dividing line, there's no difference in the level, what the magnetic field has any effect on anything, because it doesn't separate. But he theorized that there is something that he called the block wall, where there's zero magnetism in between the south and the north, and that was his theory. Okay, and I want to share with you, this is why when I talk about measuring, when I talk about measuring the field, and I show with a meter, my magnometer, that there is definitely a South Pole field coming off of this magnetic stirrer, I want to show you what Mr. Davis found in his research. So in the book Magnetic Blueprint of Life, page 41, there's this little chart here, And basically, after working for 30 years with all sorts of critters, including humans, this is what he discovered, and this is what his experiments show. That, basically the difference between negative or north and positive and south pole energy was here that when it came to, and this is a lot of this, I believe this was clearly the human clinical observations, were that the individual's performances when exposed to negative improved, work capacity improved, disposition was pleasant, reaction time decreased, improved equilibrium, enhanced metabolism, and this is where it gets very interesting. The pain was relieved, allergic disorders were relieved, and healing was enhanced. Now, when these individuals were treated with South Pole magnetic fields, their performance decreased, work capacity was erratic, they became depressed, the reaction time increased, the erratic equilibrium irritated their metabolism, increased pain, increased allergic disorders, and irritated healing. And that's what his experiments, 30 years of studying, showed these types of results. So it is definitely something when you get into this about, okay, what's happening when I leave oil sitting on a South Pole field for 2 weeks, and Mr. Davis also proved that this affects water. And so I'm going to make a leap of just assumption here that, if it affects water and you drink that water, you can drink North Pole water or South Pole water and have the same types of effects, that the effect of oil would also be the same. And that is what I'm going to stick my neck out and say. So when you put oil on a machine that generates a South Pole field, you are treating it to some negative effects. And so with that said, one of the things that I do is I try to, and this is because I'm really into this stuff, which is I neutralize the effects of exposure to the South Pole energy. And sorry if I never mentioned this before, I just didn't want to get too geeky on you guys, but what I do when I'm making my C60 oil, it's after I use the Untitled Lab. I actually when I'm letting it settle, the whole let it settle for 10 days thing, I have large biomagnets that have a North Pole side facing, and the bottom of them are South Pole, as denoted by the X, so I can always remember without having to pull out my machine or my meter. So whenever I'm done and I let it settle, this is a couple of experiments that are settling right now, it settles on North Pole. So I sit it on a magnet, it's in the North Pole field, and it sits there for practically 2 weeks, and it nullifies any effect of the South Pole, and it actually changes it back to north. Okay, so that's automatic, and that's what I do, because I feel it's very important because of the research that I want to neutralize the negative effects of being exposed to South Pole. So I know, what I just said to the common person is just new information. So one thing before I leave you on this subject, I do want to point out another person, and this is a Dr. William Philpott, who wrote the book Biomagnetic Handbook, and he spent a great number of years of his life as a doctor using magnetic fields to treat patients. And so you can get his book as well if you want, or you can read from it, but this is an excerpt from his book as well, and from all of the research that Dr. Philpott had done. When he looked at the effects from his clinical observations from the differences of patients exposed to North Pole, which is the negative polarity, or South Pole, which is the positive polarity, when he found that, hey, North Pole, it fights infection, relieves pain, there's that word again, it reduces inflammation, it encourages restorative sleep, it increases cellular oxygen, and so forth and so forth. And it really has a lot of positive effects, North Pole, positive effects, right? Now, when he did observations in the clinic for South Pole treatments, he found that it accelerates microorganism growth. In other words, and if you can read this in Albert Roy Davis's material as well, that he used the different pole on like petri dish cultures, and he discovered that bacteria and viruses grow at an accelerated rate when exposed to South Pole, as opposed to North Pole had retarded their growth rate. So I'm sorry, I don't mean to go on and on about this. It's just my passion. But anyway, it increases pain, it increases inflammation. You can just see it stimulates wakefulness, it decreases cellular oxygen, it encourages high acid levels, and that's what a South Pole magnetic field will do to you and do to your oil. And when you drink that oil, it's part of that. But if you expose yourself or your oils to North Pole energy, you get positive. And so there's two little things I want to add, just real quick. I'm going to jump, but if you ever buy a PEMF device, which is PEMF, Pulse Electromagnetic Frequency Device, and chiropractors use this all the time, you will note that they only ever used North Pole on you. In fact, if you buy one of those paddles, that's a PEMF paddle, it will flat out put, there will be an N that says this side only, and that's the reason why it's N only on those types of devices, because you only want to subject people to North Pole, because South Pole has a negative effect. And then the last thing I want to tell you is that some person on the internet actually uploaded a copy of this specific book right here, Magnetism and the Effects on Living Systems. So if you are interested in what I'm talking about, there's a link in the video description below to this book, and you can read it for free. Otherwise, you'd have to buy it. But, you know, I'm going to just stop right there because I talked way too much about magnetism. Sorry. Let's get back to stir versus sonicate. Okay, now, here's pro tips. Okay, this is awesome. Dave from C60 Labs was so generous to share with me so I could share with you his research, and this is C60 Labs miracle recipe for how to obtain a 0.8 milliliters saturation, which, remember, now 0.8 is the rat study benchmark number. Okay, but now using powdered C60, this is what Dave said, is we're getting full saturation in all our oils at 0.8 milligrams C60 per 1 milliliter oil, where there's no visible C60 residue left on the filters, but with extended spin times. Of course, this depends on the specific oils, and the source of his C60 is SCS and Solaris. So, okay, now Rog, I know you're watching this. We got Rog and I on the chat. This is like our holy grail, trying to figure out what's the perfect duration of spin for perfect saturation, right? So here you go. This is from Dave. MCT, there you go, 26 days. This is the secret formula. It's really hard to get any one of these commercial guys to help us do it at home, guys, because, you know, they're selling it and they don't want us, you know, they don't want to compete. But, you know, it's so cool that when one of them will share information with us, right? So here you go. To get 0.8 MCT, 26 days. Now, remember now, MCT does not mean 100% caprylic acid MCT. It means your run-of-the-mill, off-the-shelf MCT is usually going to be 60% caprylic and 40% capric. Okay, so that's your mix, but that's what I mean. You know, MCT could mean all sorts of different things, but I'm guessing, and this is my guess, I didn't ask Dave, I just thought about it while I'm talking, but that you're looking at a 60-40 caprylic versus capric acid MCT, and that's going to be your 26 days stir. And then hemp seed takes 23, avocado 16 to 18 days, olive 14 days. There's that rat study benchmark. And then the sunflower takes 14 days. So this is your stir times. And so I just want to say thank you, Dave, for the pro tip that I could add to this video to help all you guys at home make the best C60 oil you can. All right, let's talk about sonication. Now, if you happen to watch other videos, you will know that there's a couple of proponents, or just real strong, very respectable C60 industry folks who have come out within the last few months or so, and basically when on the subject of sonication, they say that it's bad, don't do it, that only stir, don't use sonication devices, and you know what, and they quote the reason why, and when they say why, it's true. When you sonicate oil, okay, it's going to produce an extremely high frequency wave, energy wave through the fluid, and that when it hits air bubbles, it's going to cause like a micro explosion that has incredible amount of energy and an intense amount of heat. Okay, and it basically bursts those oxygen, like little bubbles of air, and it breaks those molecules of air up, which is O2, right? Oxygen, O2, and hydrogen is usually in there as well. And so it breaks up the oxygen into O1, single atoms of oxygen. And you know what a single atom of oxygen will do? It will oxidize you, and it will oxidize your oil. And so the answer is yes, they are correct. Those individuals who have stated this are correct. I took a look at a bunch of papers, and these are the names of the papers right here, and links to every single one of these. Go for it if you want to read more. And so here's a paper called Deterioration of Edible Oils During Food Processing by Ultrasound, and the results were different edible oils show significant changes in their composition, chemical, and flavor due to ultrasound. There's another one that says ultrasound increases heat and mass transfer, disrupts aggregates, and can break macromolecular chains. And here's another one that says, therefore, these are the results. Therefore, ultrasound could increase deterioration of food lipids, and that's those liposomes, right? or that we're so in love with, because that's what we want. That's what the whole point of C60 in oil is, creating liposomes using food lipids. And then this other one, oxygen is proposed to be involved since purging with nitrogen diminishes any viscosity drop observed, and select ion flow tube MS analysis violates from the oils after sonication indicates an increase in the number and quantity of oxidized products. So, point number one, when it comes to sonication, yes, it will oxidize the oil, and then oxidation increases the speed at which the oil will go rancid. So, do you want to oxidize and make your oil go rancid faster? Obviously you don't. So their advice to not use sonication is spot on that point. That's point number one. I'd like to share with you point number two. Other documents here, and these are other studies, so you can go and read them all you want. Here's effects of ultrasound treatment and Xenia essential oil on lipid oxidation of blended vegetable oils. Here's another one, effects of ultrasound treatment, UV radiation, and something essential oil on oxidative stability on sunflower oil, and effects of ultrasonic treatment on extraction of fatty acids on flaxseed oil. Okay, so what were the results? Okay, and you could read these science studies. Now, the results on the first one. Results showed that ultrasound treatment increased oil oxidation. Yep, we know that. That's point one. Point two, but EO, or I guess that's extra olive oil, can act as, EO meaning essential oil, sorry. EO, essential oil, right, Xenium, can act as an antioxidant and increase oil stability. Okay, this one says, the results indicate that ultrasound and UV could accelerate lipid degradation, point one. However, and the addition of the essential oil as a natural antioxidant significantly reduced lipid oxidation and improved oil stability. So this one proved what this guy proved. And then this one here, this last one, or this third one, the chromatic, sorry, I just can't pronounce that right now, showed that there were no significant effects on linoleic acid by the ultrasonic assisted extraction. Okay, so these are science studies where they're using sonication devices on oils. And the point two that I want to make is that when you add, and this is a type of essential oil, this is a different type of essential oil. And what are these essential oils? They are antioxidants. And what is C60? It's a antioxidant. In fact, it's a super antioxidant. And if you read the rat study one more time, they determined that it was 272 times more powerful than vitamin C as an antioxidant. So, what happens when you add an antioxidant to oil that you sonicate? You get improved oil stability. There you go. Increased oil stability. It mitigates the negative effects. It doesn't eliminate, it mitigates the negative effects of sonication on lipids by having an antioxidant present in the solution. Point number two. Okay. One more point number two was, here's another study, effect of sonication at different ultrasound frequencies. So now let's talk about what the frequencies are. Does it matter? And the results were, I forgot to make it italic. Sorry, I'm sorry, I'm an OCD. It was concluded that extraction of oil from C. vulgaris, is a type of oil, at sonication they tried it at 20, 40, 60, and 80 kilohertz. So at different kilohertz, does it make a difference? It had no degradative effect on the structure of the fatty acids. So it didn't, these four frequencies, it didn't make a difference what the frequencies were. If you added antioxidants to the oil, it improved the oil stability. And then and that's point two, right? Here's point three that I want to share with you. And this is just the science. Make your own decision. Read the study if you want. I'll give you my opinion at the end. But the point three is these two studies right here, or these two papers. One paper was ultrasonic processing and its use in the food industry, a review, and the other paper was called the use of ultrasonic in food preservation. Now this is what's coming from the industry. This is the food industry. And if anyone's more anal retentive about the food quality and preservation and you name it, they got to get it from point A to the store, and they want it to last as long as possible so they can sell it, right? And so they don't want to throw it away because it expired. So this is a big deal when they use this in the food industry. And so this result here from this paper, it says ultrasound are sound waves having frequencies beyond the audible range. And we know that. greater than 20 kilohertz, but it has a variety of applications with many advantages as compared to conventional methodologies used in food industries. And what that means is, if you read this paper, they talk about using ultrasonic processing to basically kill off all the pathogens and basically, I guess not necessarily, clean it up or get rid of all the pathogens, purify it, whatever. I'm just lost the word for that. But they use it to treat food before they ship it out, and oils as well, so that it comes out, it doesn't have any pathogens in it, and they're actually looking at this as a very positive new thing for the food industry. Now this paper right here talks, the results were low power ultrasound is thought to be an attractive non-thermal method due to overcome problems which occur during heat treatments such as physical and chemical changes, nutritional loss, and change in organoleptic properties. Okay, now this one right here, pasteurization. I'm sorry, that's the word I was looking for. In pasteurization, they have to get it up to like 170 degrees or something. They got to make whatever they're trying to pasteurize. They have to heat it up really high to kill off all the pathogens. But what the paper says is that, they sometimes when you heat up something really high, you mess up the flavor, you mess up the composition of the food, whatever ingredient you've got in there. And so they've been looking for ways to pasteurize without having to heat up. And you could pasteurize food or different edibles and things like that in a sonication bath, right? In an ice bath, so that it's not going to get heated up but have the same effect that in terms of pasteurizing the fluid or whatever you're trying to, the food, right? And that's what this one talks about. So that's point number 3. Point number 3 is that they're using it in the food industry. And so if anybody that's going to be completely paranoid about sonicating stuff, about making things go rancid faster, it would be these guys. But they're using it, and they're exploring using it. And so point number 3 is that if the food industry is really looking into using this, and if you add antioxidants to it, it mitigates the effects, then when you look at point number 1, it's like, okay, point number 1 taken. All right, it does that. But point number 2 mitigates that. Point number 3, the food guys are looking into it. And then the last thing, and I don't have a slide for it, but I just want to say something about low power ultrasound. And so, if you've ever been married and you have your wife and you guys go in and get your ultrasound, what do you think that is? That's sonication. It's very low powered sonication, and if you go into the video description, I have a paper in there called Application of Ultrasound in Medicine, okay? And in that paper, it basically says that the ultrasound that your wife is exposed to, or you, when you're having your baby looked at, is anywhere from 3 megahertz to 10 megahertz, okay? So I want to point out that that's really, really high. When we're looking at, when you're looking at using one of these puppies, you're looking at anywhere from 20 kilohertz. And the ultrasound that they use on pregnant women is 3 to 10 megahertz. So let that sink in. Point number 4, if it was really, 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 really bad for you, you certainly wouldn't be using it on babies and pregnant women. So point number 4, ultrasound on pregnant women. So now I'm going to leave you with that. My humble opinion is that it is absolutely not an issue to use a sonication process to create liposomes for your C60 oil. I think it's very important, though, that it be a short period of time at a lower frequency, and also using a bath versus a probe. Let me get into that in a little bit. But that's my opinion, and we all are allowed to have an opinion. But these are the 4 points I wanted to make about sonication, and you guys can make your own decision and have your own humble opinions, and I would love to hear from you in the comment section. Okay, now, so enough about that. let's just talk about sonication, all right? So now the concepts here, these are just like the magnetic stirrs, a lot of the things you need to think about. You got probe versus bath, the capacity of the machine, the power of the machine, the temperature. These things come with heaters and they don't, just like magnetic stirrs, and what frequency to use. But first, before I get into that, I really want to talk about some safety tips, because with a magnetic stirrer, you're not going to hurt yourself. But with one of these, you can have problems. So these are my lab safety tips about using sonication machines. Hearing protection. Now, if you're going to be in this, if you have to be in the same room, put something in your ears, because it will drive you crazy, because of those things just have this really high pitched whine to them, and it's clearly not good for your brain. Okay, and then the when you're using a bath version, which is like this big tub here, and you fill it full of water and you put your flask in there, when you're using that, you absolutely should only use Pyrex or borosilicate glass, which are the lab glass. Okay, don't use your kitchen glassware, because that glass may not be sufficient to not break. Like the opera singer and the wine glass thing. So only use lab glass, which is meant for really high temperatures, really low temperatures, and meant to withstand a lot of beating up, just a lot of paint. So you can definitely put one of these in a bath, in a sonication bath, and I've done it a lot of times, no problem at all. Okay, so just don't use regular glass. And then of course, as I was talking about temperatures, I believe in lower. That's my opinion again, that lower temperatures are better. So have ice or cold water on hand, and that's what I do, because I keep it really cold. Okay, and then definitely buy one with a timer. If you're going to do it this way, or if you want to try this out, just buy it with a timer, because there's nothing worse in life than having a machine you got to keep going back to every few minutes to just reset it again, like an egg timer. It's horrible. But anyway, and then do not sonicate oil in the steel basin. Now, if my original first time videos about this, I didn't know that at the time. So this is the 29 updated version of don't put the oil in the steel basin. Put water in the steel basin. Put your oil in a flask and put the flask in the water, okay? And the reason is the ultrasonic waves are so intense that it'll literally strip off ions, the metal ions, off the inside of the basin as it operates. And if your oil is in the basin, it'll release those metal ions into your oil, and when you taste it, it'll taste metallic. And you certainly do not want stainless steel ions in your body. So don't just put it in the basin, put it in glass, put the glass in water. Okay, now make sure the beaker fits. You would not believe how stupid sometimes I can be, and so that's an issue. And then anyway, make sure it's the right size. And then do not let the beaker touch the bottom of the basin. Okay, that's not good. You don't want it to touch the sides. So use the basket that the thing comes with and put it in the basket. Okay, you don't want it to touch the side, and the reason is you could burn out the transducer that's attached to the bottom of the basin by having that much weight sitting directly onto the actual bottom of the basin. Okay, so don't let it touch the sides or the bottom. Okay, keep it in the basket. Those are my K-Elmer safety tips using sonications. All right, let's talk about probe versus bath. Now, these are the different types of devices you could get. Now, there's the homogenizers, and they basically are like probe type devices, where the probe, instead of you putting your glass into water like these guys, ultrasonic cleaners, where you just fill this thing up full of water, you put it in, or the big ones here, like this is 72 liter size, you got the big old pipe, and it's just water, and you put your flasks in there. These guys actually the opposite. They just have the flask, but then they put the probe inside. Now you can get those. You can get ultrasonic cleaners that have mixers that have the probes going into the solution, or you can have it where it's a bath. So this is probe versus bath, and then there's this other thing called ultrasonic mixers, which pretty much do the same thing that these guys do. It's just they just have a different terminology for it. But these two are pretty much you put it inside your solution. So you've got metal in your oil, or you've got your oil in a glass in water. Highly recommend the bath, because first of all, these things are 1,000 times more powerful than these things, because these guys, your oil is sitting in a bath of water, and the machine is passing through all of that water and your oil, okay, as opposed to the energy coming right out of the probe directly into your solution. And guess what I talked about metal earlier, okay? So I just absolutely don't, I've seen videos of people making C60 oil using it this way, and I just, in my humble opinion, I don't think that's a good way to do it. I prefer the bath method. I think it's it's much more gentle in terms of those micro explosions and things like that. Using a bath, and you can really control the temperature with ice and cold water, as opposed to the temperature this thing is going to get really. How would you keep this cold? Right, it'd be very difficult to keep it cold. So it's easy to keep it cold. There's not much. It's not as powerful, so that there's less energy. Less energy is a good thing when it's 1,000 times more powerful. So the different devices. Probe versus bath, in my humble opinion, bath wins. Okay, now let's talk about capacity again, power and frequency. So for C60 oil, okay, again, bath, not probe, just went over that. Capacity measured twice by once. Okay, so now this is the exact model that I've used. You saw this, if you did, in the how to make C60 with pulverized C60 oil. A video, but this is my machine. It's a dual 20 hertz kilohertz digital heated, so it's got a heater and it can go up to 40, as you know, high frequencies, anything over, well, when I talk about frequency, let's talk about that. The frequency range, and this is some professional advice from Lion Biomedical, is it's go from 20 to 28. That's what he recommends. The sweet spot is 21 hertz. But he goes with 28s because, it's easier. He basically gave me some advice at 28 because it's much easier to buy a 28 kilohertz ultrasonic device than it is to buy a one that you can dial to 21. So anywhere between 20 and 28 is the perfect frequency range for oils. So when I use my machine, I always set it at 20. The sweet spot is 21, but there's no machine I can find that I can literally set it to that exact frequency. Okay, but this is his range that he says is okay for doing oils. And then the other thing too about power is that more power does not equal less time. So here is a quote from an exchange that I had with him, but he basically said, so greater watts and more power does not lead to a shorter sonicating time. But they use, okay, this is Lion, we use 400 watts with 10 transducers. However, if we used 1,000 watts, right, much more watts, we'd still need to use the same sonicating time. So you've got a pro tip from Lion Biomedical that more power does not equal less time. So don't worry about power as much as you should worry about keeping the frequency low, keeping the temperature low, okay, and using a bath versus a probe. All right, so that's something to keep in mind. Now with this puppy here, this is a 3-liter, and I found out backwards, I didn't think about it ahead of time, that it fits a 500 milliliter flask perfectly. It's like made for a 500 milliliter flask. So 3 liters equals 500. That's kind of your starting point if you ever decide to go buy one. But again, measure twice, buy once. So whatever glassware you plan to put in the machine, make sure that you get the specs on the inside compartment, how high the water goes up, so that it will fit, so that you don't buy one that your glassware doesn't fit like I did once. Okay, so these are the main points: bath, capacity, power, temperature, and frequency. All right, so that's that. Now I want to share with you some pro tips, and the reason I'm sharing pro tips with Lion is because Lion is one of the more commercial. It's not one of the more, I guess I was going to say famous, but not famous, but I guess what's the word for it? Reputable providers of C60 oil and C60 products on the market. Just most people have nothing but just great things to say about the folks there at Lion. I really like them myself. There's another vendor out there that does sonication, so it's not just Lion using sonication. There's more than one, and most I have to admit that most, I would say, maybe the high percentages, like 80% actually stir versus Sonicate. But there are a couple of commercial vendors that do Sonicate, and their products are very well respected. Okay, so I'm quoting Red Lion here because I see them as an expert in the field of making C60 oil, especially in making C60 oil using sonication. So we got a pro tip here. And this is our second, and this is probably the most valuable pro tip he could have ever given us, because I never knew, if you saw that video that I made about how to use his product to make C60 oil. At the time, he didn't want to share. It was his secret sauce, and I respect that. But I asked him again if he would mind sharing that, and he actually did. And thank you so much for sharing this information. And again, like I said about C60 Labs, it is very rare for a commercial maker to share their knowledge and their secrets with us do it at home guys. But and Martin was very kind enough to do so. Thank you. And so this is what he shared. Now, he said how to make Red Lion C60 using pulverized C60 was you mix the PC60 with oil, and you do it gently by hand, like you're folding in a meringue. Okay, and so you don't want to just be really gentle, and you just stir it up, and then sonicate it immediately. And in this specific example, he was talking about a 28 kilohertz sonication device. Okay, and he mentioned 28 specifically because he said it was a lot easier to find a 28 than it was to ever find a 21. But he said if you can get a 21, or get one that you can dial down to 21, that's perfect. But if you can't, 28 is fine. And and also I got a 20, so those are 20 or 28. But he's this specific description was at 28 hertz. So the thing is once you stir it in by hand gently, and you don't do it for very long, you just get a good, get a good mix. Then you want to sonicate it immediately. And here's the secret sauce. It is, and this is his words, approximately, no more, no less, approximately 279 seconds per liter. All right? That is a very secret number that he was generous to share with us. So that's only like 4 minutes and something seconds, okay, per liter. And he basically was very adamant, no more, no less. Don't mess with it. Just 279 seconds per liter, okay? And that's as much as you sonicate. And he said room temperature, all right? And then you just cover it up, and then you mix it occasionally by hand, very gently, for 1 week, and then just leave it alone for 2. Now, that's a minimum 3 weeks total, but then he also said that 4 to 5 weeks is better. So if you really, really wanted to do it, I guess I forgot an S there. If you really, really wanted to, seek perfection and make a commercial quality product, then this is how you're going to do it, and you'll let it just go for 5 weeks. Go the whole distance, just leave it alone. And he was so adamant about leaving it alone. Just don't mess with it. Don't use magnetic stirs. Don't just stir it up, girl. It's gentle. And you know what was it just killed me when I read this and we were talking to each other. I was like, oh my gosh, I've been beating the crap out of my oils. I've been like stirring for 2 weeks and doing all sorts of stuff with pulverized. And I never thought about going the other direction and doing less, but that's the secret sauce, guys. Once you let it sit there for those 3 to 5 weeks, and then he says he filters using a 0.5 micron bag filter. So he doesn't even use vacuum filters. He uses a bag filter. He just let it gravity, and then boom, and then he said, and this is not on the slide, but after you filter, he just bottles it up and he leaves it sit for 3 weeks before he ever sells it. So that's courtesy of Red Lion, the pro tip on how to use a sonication device to make Red Lion C60 oil perfectly. And one of the cool things about Red Lion is that it comes out red, not brown. So when you all know this, you make olive oil C60, it comes out brown with a red tinge. This comes out red. It is that pure. So there you go. There's your secret sauce pro tip from Red Lion. And that concludes this video. Stir versus Sonicate. Everything I've collected in my brain since last year, or more than that, since I've been doing it. So, if you've made it this far in the video, Good job. Thank you so much for spending time with me and to listen to this video. And I hope you learned something. I hope the information I have is valuable to you and that it helps you, because that's all I do this for. I only do it for one purpose, and that's to share information and help other people so they can go and help their loved ones and their pets and do everything they can to just, make life better. And so thank you so much for your time. Thank you for your generosity and your comments, and thank you for stopping by and watching this video. Now, the last thing I have to say is, if we do have a Telegram C60 chat group for anybody who has any kind of question about anything. There's all 400 members now. They'll just answer any question you have. If you're trying to make your own, or you got, what do you buy, devices, all that stuff. And feel free to jump in and just join our group, and welcome. Everybody is welcome. And there's one little thing I got to let you know, that we've just been getting spammed like crazy on Telegram. And so we've had to lock down the chat groups to invite onlys. But everybody's welcome. Just direct message me for an invite, and I'll send you the link, and then you can join in. Okay, so that's the only difference that we've made lately, is we had to lock it down because of spammers, but it's still an open chat group. We're still in there chatting about C60 all the time. So everybody welcome. Got questions? We're very easy to get a hold of. I also check the comment section, and I answer questions there. So that's it. So thank you again. Aloha, and have a great day. Bye.